Find the slope of each line. The slope is determined by calculating the rise over run. And literally what you do if you're given a graph with 2 points on it is you determine how far you go up and how far you go over. But there's two other things that we have to be careful of too. Thing number one is if your line is going up and to the right or down and to the left, it's a positive slope. If it's going down and to the right or up and to the left, it's a negative slope. So when I look at this guy, not only am I saying, all right, here's a point, it's going up 1 over 2. That tells me that it's 1 over 2, but that's not all I have to worry about. Since this is going up and to the right, it's positive 1 over 2, which means I'm done. I don't need to do any more. Now this guy, here's my 2 points that I'm given. So here's a point, here's a point. I'm going to do my rise over run. So I'm going to go down 1, 2, and I'm going to go right 1, 2. So down 2, right 2. But not only do I have to worry about the numbers, I know it's a negative slope because it's going down and to the right. So negative 2 over 2. Now the difference between this guy and the last guy is I can simplify this. So 2 divided by 2 is 1, which means negative 2 divided by regular 2 is 1. And so my final answer here is negative 1. So that's how you find the slope of a line with points already given to you. Find the slope of each line. Now, whenever you're determining the slope of a line, what you need to do is find what's called the rise over run. Now, not only do you do rise over run, you have to determine a few things. If your line is going up and to the right, it's a positive slope. You can also say down and to the left. If your line is going down and to the right or up and to the left, it's a negative slope. So what we have to do is we have to find 2 points and calculate rise over run and then label it positive or negative. Well, we have issue number 1. I don't have any points. So what I'm going to do is I'm going to create points by finding spots on a line that makes sense. Now, if I look at this, like I'm not going to put a dot right there or a point right there because I can't really tell what that is if I go up or down. That is definitely a point that crosses. And you know what else? That guy is 2. So I'm going to use these 2 points. Now you might be looking at this and saying, oh, I could use other points, right? Sure, but these are the ones that I'm using because they definitely cross over. Now I'm going to calculate the rise over run. I'm going to count up and then over to get from one point to the other. It doesn't matter which order you go in as long as you remember these rules. So if I go from the bottom, like Drake, that's where he started, and go up and over, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And then I go over 1, 2, 3, 4, 5. So my rise is 8, my run is 5. However, since this line is going down and to the right or up and to the left, my answer is negative 8 over 5. Nothing simplifies, nothing simplifies. Now when I go over here, this doesn't follow either of these rules, which takes us to a new set of rules. If my line is perfectly horizontal, my slope is 0. That's not what I have. If my line is perfectly up and down, it's undefined. Now, if you're wondering why it's undefined, I'll explain it in a second. By the way, that's my answer here, is undefined. Now, if you're wondering why, well, my rise, if I were to pick 2 random points like here and here, my rise would be up 1, 2, so my rise would be 2, and my run would be nowhere. I don't go left or right, so it's going to be over 0. Well, you can't have anything over 0. You can't have 0 in the denominator. That makes it undefined. So when your slope is up and down, it's undefined. If you're wondering why is the 0 slope 0, that's because you rise nothing and run like a number. 0 divided by 2 is 0, so that's why this makes sense. So again, we are looking at positive slopes looking like U, negative slopes looking like U, zero slopes being left to right perfectly, and undefined slopes being up and down. And you calculate rise over run by making 2 points of your own. Isn't that fun? Find the slope of the line through the pair of points. Well, in order to do this problem, we are going to need the slope formula. The slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's the slope formula. If you're wondering, well, where do you get these numbers or letters from? What does that mean? What you do is you label your 2 points, and it doesn't matter which is which. Label your 2 points x sub 1, y sub 1. That's going to be one of your points, and the other point x sub 2, y sub 2. Now, it doesn't matter which ones get the 1s and which ones get the 2s, as long as you keep them together. x1, y1, and x2, y2. Your answer in the end would be the same if we flip-flop this, as long as you have xy, xy, and 1, 1, 2, 2. Now that I know this information, I'm going to substitute these numbers in to those variables. Y sub 2 is negative 7. So I'm going to rewrite this out and replace y sub 2 with parentheses negative 7. Close the parentheses, minus sign in the middle. Y sub 1 is negative 19. So parentheses negative 19, close the parentheses. X sub 2 is negative 2, so parentheses, negative 2, close parentheses, minus sign in the middle. X sub 1 is 1, so parentheses 1, close parentheses. Now what we're going to do is we're going to take a look at what I have, and if I have nothing in front of the parentheses, I'll realize that the parentheses is useless. And if I have a double negative, that makes my number become a positive. So minus negative 19 becomes plus 19. Negative 2, nothing in front of the parentheses, so I don't need the parentheses. Minus 1 is just going to be minus 1. So this is me just cleaning it up a little bit. Now I do the math in each side of the fraction bar separately. Negative 7 plus 19 is 12. Negative 2 minus 1 is negative 3. 12 divided by negative 3 is negative 4. So the slope connecting these 2 points is going to be negative 4, which is going to look something like this. Okay, a negative slope going up and to the left or down and to the right. And since 4 is kind of a big number for slope, it's going to be kind of steep. But if I were to graph these 2 points on a coordinate plane, my slope would look something like this. And that's how I calculate it. Find the slope of the line through the pair of points. Whenever I have to find the slope of a line, I'm going to use what's called the slope formula. And that's m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, what are these x's and y's with those little numbers attached to them? Well, what we're going to do is we're going to label these points x sub 1, y sub 1, and x sub 2, y sub 2. If you're wondering why I called these the 1s and these the 2s, there's no reason. I guess because that's the first point and that's the second. The reality is I could have called this point x sub 1, y sub 1, and I could have called this point x sub 2, y sub 2. The order is not going to be a big difference. What matters is making sure you have x, y, and the same numbers grouped together. But since this is what I chose, I'm going to use these labels to plug them in. Okay, so y sub 2 is negative 15, and when you substitute negative 15 or any number into any of these, you're going to replace them with parentheses and that number. So y sub 2 becomes parentheses negative 15, close parentheses, minus sign. Y sub 1 is parentheses negative 16, close parentheses, all over. X sub 2 is parentheses negative 7, close parentheses, minus sign in the middle. X sub 1 is parentheses 19, close parentheses. Now what I'm going to do is I'm going to clean up each part. If there's nothing in front of the parentheses, I don't need the parentheses. So negative 15 doesn't need a parentheses there. This is a double negative, and a double negative makes this number positive. So minus negative 16 is the same as plus positive 16, so I'm going to clean that up. Nothing in front of parentheses negative 7, so I don't need the parentheses. And minus parentheses 19 is just minus 19. Now that I have that cleaned up, I'm going to do all the math in the numerator and then all the math in the denominator and see what happens. Negative 15 plus 16 is just 1. Negative 17 minus 19 is negative 26. Now I'm going to clean that up by just bringing the negative out here, which I'm allowed to do because a positive divided by a negative makes the whole thing negative, and I get negative 1 over 26. Now what this looks like from a graphical point of view is a very, very, very shallow negative line. Even more shallow than that, because if I were to try to describe this as a slope, as rise over run, I'd go up 1 space and go over 26. So you're looking at a very, very, very shallow line. But that's how I do it. I use the slope formula, I label my points, I plug in my points, I do a little bit of math, I get that, and the visual representation is a very shallow negative slope. Find the slope of a line through the pair of points 17, negative 13, and 17, 8. Now I know what's going to happen, but let's pretend we don't. We are to find the slope of 2 points, and what I'm going to do is I'm going to write out my slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Then we label our points x sub 1, y sub 1, x sub 2, y sub 2. And if you're wondering, why did you call these x sub 1, y sub 1? Well, this is an xy, and since this is my first point, I gave them the 1s. This is an xy, and since this is my second point, I gave those the 2s. And if you're wondering, like, well, couldn't we flip these? Sure we could, and nothing would change. Just make sure you have it in xy, and just make sure you line the 1s with the 1s and the 2s with the 2s. But since I have that, I'm going to substitute these values in using the things that I labeled. So y sub 2 is going to become parentheses 8, close parentheses. Here's the minus sign. Y sub 1 is going to be parentheses negative 13, close parentheses, all over. X sub 2 is going to be parentheses 17, close parentheses. Drop the minus. X sub 1 is going to be parentheses 17 again, close parentheses. Now, like I said, I know what's going to happen. Let's clean up the numerator, the denominator. If there's nothing in front of a parentheses, you don't need the parentheses anymore. This is a double negative. Minus a negative is the same thing as plus a positive, so plus 13. Since there's nothing in front of parentheses 17, I don't need the parentheses. Minus 17 looks like minus 17. Now, 8 plus 13 in the numerator is going to be 21. 9 plus 10. 17 minus 17 is going to be 0. Now, this is a problem. You're not allowed to divide by 0 at all. And when that's the case, you get undefined. So my slope here is an undefined slope. Now again, I said I knew this would happen. Good job drawing the box by me. I said I knew this would happen because what I noticed is that right away the x's are the same. And when the x's are the same, you are going to draw 2 points that give you an up and down line. So a shortcut is if you notice this right away, that the x's are the same and you're trying to find the slope, the answer is going to be undefined. Now, a flip-flop of that is what if the y's are the same? Like, what if I gave you something like 17, 2, and 8, 2? Well, you could apply the same rules, but flip it around. If the y values are the same, then what you would graph would be something that looks like this, which is a 0 slope. So this is a special problem where when the x values are the same, I technically don't have to show any work, and I know immediately that the slope is going to be undefined. If I gave you a problem where the y values are exactly the same, I don't have to show any work, and I can stop right there and say that the slope is 0, because I would get something like 0 over a random number, which just calculates out to 0 anyway. Okay? So that's a fun little shortcut that you can memorize if it helps. Find the slope of the line from the equation. I am given an equation in what's called slope-intercept form. So what I'm going to do is I'm going to compare this to slope-intercept form. Slope-intercept form is y equals mx plus b. When y is all by itself, The number in front of x is my slope, and the number floating around is my y-intercept. So what I can do is I can line everything up, and notice that the number in front of x is my slope. Now, there's no number there. It's just a negative symbol. Well, if it's just a negative symbol, you have negative invisible 1. Now, I know that looks terrible, but that's negative invisible 1. So I know my slope is going to be negative invisible 1. The number that's floating around, if y is all by itself, is going to be my y-intercept. So since b is positive 3, that means my y-intercept is also positive 3. So again, when y is all by itself, the number in front of x is my slope, so negative invisible 1. And when y is all by itself, my number floating around is going to be my y-intercept, so positive 3. Write the equation in slope-intercept form. I am given an equation in this form right here, which is technically standard form, and I'm being asked to write it in slope-intercept form. Slope-intercept form is y equals mx plus b. So what I have to do is get y all by itself and have my x value first, my x term first, and my number floating around all by itself second. So I have a little bit of work to do. I have to get x over on the right side, and I have to eliminate anything in front of y. What I'm going to do first is, if you have an x value floating around on the left, get rid of that first by doing the inverse operation. This is a positive 9x. I'm going to get rid of a positive 9x by subtracting 9x from both sides. That allows you to cancel out. What I then do is I drop down negative 7y equals. Now, negative 7 and negative 9x don't combine because you are a constant and you have an x attached to it. Now, I can't combine them. What I'm going to do is write it out in this order. I'm going to put my negative 9x first because I want my x term first, and then minus 7. I want it in that order so that when I do this next step, I'm done. Now, what is the next step? Well, y is not all by itself yet. So what I have to do is get rid of the negative 7 that's attached to y. How do I get rid of a negative 7 that's being multiplied to y? Divide negative 7. Now, when I divide negative 7 from the left, I divide negative 7 from everything on the right. That allows me to cancel that out. And now y is all by itself, so I'm in much better shape. Negative 9 over negative 7, negative over a negative is a positive, and 9 over 7 doesn't simplify. I'm going to leave it as that, as an improper fraction, because I want my number to be a regular old improper fraction to look like rise over run. Drop the x down. Negative 7 divided by negative 7 is positive 1. So I'm going to put plus 1. Now that y is all by itself, I have my x term first and my number, my constant that's floating around second. I now have something in slope-intercept form. So that's how you do it. Find the slope of the line from this equation right here. 4x plus 5y equals negative 10. Well, here's an issue. I can't just look at this and determine my slope because it's not in slope-intercept form. Slope-intercept form has y all by itself equaling my x term plus my y-intercept. My slope is the number that lives in front of x when y is all by itself, and that's what I'm trying to find here. So what I need to do is get y all by itself. Here's the issue. 5 is attached to y, and 4x is floating around with it. The thing that I have to do first is always get rid of the x term by doing the inverse operation to both sides. Now, 4x is positive 4x. How do I get rid of a positive 4x that's floating around? Subtract 4x from both sides. That crosses it out. You drop down positive 5y, drop down the equals, and now I have negative 10 minus 4x. Here's the thing, negative 10 minus 4x don't combine, so I'm not going to combine them. You're a constant, you're an x, they don't combine. What I'm going to do though is, since I want it to look like something x and something, is I'm going to write out my negative 4x first, then my minus 10, because this looks a lot more like this. Now, is y all by itself? No. I have 5 being multiplied to y. So how do I get rid of a 5 that's being multiplied to y? Divide 5 from everything. Divide 5 from everything. Okay, that crosses out. Y equals, and we're going to simplify each of these on their own. Negative 4 over 5 doesn't simplify, so we're going to leave it as negative 4 over 5 and attach the x. Negative 10 divided by 5 is actually negative 2, so minus 2. Now that y is all by itself, I have slope-intercept form. My job is to find the slope. Well, when y is all by itself, the number attached to x is the slope. So my slope is that guy right there, negative 4 over 5. So since y is all by itself, the number in front of x, negative 4 over 5, is going to be my slope, and that's my answer. Now, all I had to do for this problem was find the slope. If I wanted to find the y-intercept, it's negative 2. But I didn't have to do that. That was just a little added bonus for you. Find the slope of the line from the equation negative 30 plus 10y equals negative 2x. Well, in order for me to find the slope of a line, if it's not in slope-intercept form like this guy is to put it in slope-intercept form. Slope-intercept form is having y all by itself, then writing out the x term, so mx plus b, and having a number floating around. I need to make this look like this. And once I do that, I can find the slope by noticing the number in front of x. When y is alone on the left, the slope is the number attached to x. I'm not even close to that here. What I have is I have negative 30 plus 10 glued to y. Now, whenever I have a number floating around on the same side as y, I'm going to get rid of that guy first by doing the inverse operation. I have negative 30 floating around. How do I get rid of negative 30 that's floating around? The inverse, which is plus 30, and I'm going to do that to both sides. So I'm going to cross u out, drop down positive 10y, drop down my equal sign, and then take a look at what I have over here. Now, these two are not like terms. You're negative 2x and you're positive 30, so they don't combine. So I'm going to write out negative 2x plus 30 in that order. Why in that order? Because I want this to look like y equals mx plus b, and if I have my x term first and my constant second, that makes it look like slope-intercept form. Now, am I done? No, because my job is to get y all by itself. Y isn't all by itself. 10 is being multiplied to y. How do you get rid of a 10 that's being multiplied to y? Well, you divide 10. If you divide 10 from everything, from both sides, you literally divide 10 from everything. That crosses out. Y equals negative 2 over 10 is negative, and 2 over 10, they're both divisible by 2, simplifies to 1 over 5. Negative 2 over 10 simplifies out to 1 over 5. X comes along for the ride, and 30 divided by 10 is going to be positive 3, so plus 3. Now that y is alone all by itself, I know that if that is the case, the number in front of x is my slope. So I'm going to say that my slope is the number in front of x, which is negative 1 over 5. If I knew how to circle better, that would be a whole lot better. But I already made this video, and I made it this far. I'm not erasing anything. But my number is the number in front of x, my slope is the number in front of x when y is all by itself. Now, if I asked you to find the y-intercept, there it is. It's 3. It's the number floating around when y is all by itself. But I didn't ask you to do that here. I just asked for slope, and slope is negative 1 over 5. Graph using slope-intercept form. I am given an equation in slope-intercept form already. Slope-intercept form is y equals mx plus b, where the number in front of x is my slope, and my number floating around is my y-intercept. Now this problem is very nice because it's already in slope-intercept form. The number in front of x is my slope. So that tells me that my slope is 1 over 4. My number floating around is 2. That's my y-intercept. So that tells me that my y-intercept is 2. Now, whenever you're graphing a point in slope-intercept form, you have to identify your slope and your y-intercept. I did that. Now that I know what they are, you're always going to start out with your y-intercept. My y-intercept is 2. So I'm going to go over to my coordinate plane and put a point on the y-axis where 2 is, like so. What I do is I take the fact that my slope is 1 over 4 and I draw more points, as many as I can. This slope is positive 1 over 4. That means I'm going to go up 1 and right 4 because it's a positive slope. Remember, positive slopes go up and to the right. So I'm going to go up 1, right 4. Up 1, right 1, 2, 3, 4, and put a dot. Up 1, go right 1, 2, oh boy. I'm out of space. I can't make any more dots. So here's what I can do. Instead of going up 1 over 4, I can go down 1, left 4. So go back to your original dot, go down 1, left 1, 2, 3, 4, put a dot there. Down 1, left 1, 2, I'm out of space again. That's okay. I have 3 points. I technically only need 2 points, but 3 points will certainly do the job. So what I'm going to do is I'm going to take this line here, because I'm not even going to pretend like I'm good enough drawing it, and I'm going to connect the dots using that line right there. So once you have your dots, you draw yourself a line connecting the dots, and you have yourself a linear equation being graphed using slope-intercept form. Again, start out with your y-intercept, and then use your slope to make more dots. Once you have a bunch of dots, connect the dots using a straight line, and you have your linear equation. Graph using slope-intercept form. Slope-intercept form is y equals mx plus b, where the number in front of x is your slope and the number floating around is your y-intercept. Well, this guy is already in slope-intercept form because y is all by itself. So what does that mean? Well, the number in front of x is my slope. So my slope in this case is negative 6. Now I'm going to draw it out like that because I'm going to change that in a second. My y-intercept is 3, so my y-intercept is 3. Now remember, slope is rise over run. So if I give you a slope of negative 6 or a whole number or an integer, you're going to put it over 1 because you're viewing it as rise over run. My y-intercept is 3. Now, whenever you graph a line in slope-intercept form, you always start out with the y-intercept. Put a dot on the y-axis where your y-intercept would be. In this case, I'm going to put a dot on 3 because my y-intercept is 3. My slope is negative 6 over 1. This is a negative slope, which is up and to the left. So I'm going to go up 6, left 1. So let's go up 1, 2, 3. I can't go up 6, left 1. So that also means since I can't go up and to the left, I can go down and to the right. So I'm going to go down 6, right 1 instead. Down 1, 2, 3, 4, 5, 6, right 1. down 1, 2, 3, uh-oh, I'm out of space again. That's okay. Once I draw as many dots as I can, my next step is to draw a line connecting the dots. Now, whenever you're drawing a line, you really only need 2 points. So I'm going to draw this line connecting these 2 dots, and I'm done. That's it. So the process is you label your slope and y-intercept, put a dot on the y-intercept, make as many dots as you can, and connect the dots. If you have 15 points, then draw a line through 15 points. In this case, I only have 2 points, so I'm going to draw a line through just those 2 points, and I'm done. Graph using slope-intercept form. This really doesn't require slope-intercept form. This is a special case, and here's why. You're just given y equals a number. When you have y equals a number and no x is attached anywhere, you are going to have a horizontal line like so. So this is how you graph it. It's very simple. Go to where y is -5 and put a dot there. And then you just draw your horizontal line through that -5 like this, and that's it. You're done. Okay, so if you're given y equals a number and you're being asked to graph, it's going to be a horizontal line that goes through that number on the y-axis. You're done. Graph using slope-intercept form. Well, this is one of those rare cases where slope-intercept form isn't going to help you because this is a special case. This is x equals 5. Whenever you're given x equals a number and nothing else, no y's, it's going to be a vertical line. So what you do is you go to the x-axis. Since x is 5, you put a dot on the number where the x-axis exists, and then you draw yourself a vertical line through that 5. So let me put that there, and let me put that there, and that is my answer. So again, anything in the form x equals a number where there's no y's anywhere in the problem is going to be a vertical line up and down going through that number seen on the x-axis. And that's it. Graph using slope-intercept form. Well, this is not in slope-intercept form. Not yet. Slope-intercept form is y equals mx plus b. Now, the reason why slope-intercept form is so useful is once you have y all by itself, the number in front of the x is your slope, and the number floating around not attached to x is your y-intercept. So what I need to do is I need to get this into y equals mx plus b form before I can graph it. Now y is on the left, but so is 7x just floating around. If you have a 7x or the x term floating around on the left side or the same side as y, you do the opposite or the inverse of it to get rid of it. So we're going to subtract 7x because this is a positive x, and we're going to subtract 7x from both sides. That allows you to eliminate. Drop down the y. Now, I want to make this look like slope-intercept form. So rather than me saying 5 minus 7x, I'm going to write out negative 7x, and since that's positive 5, plus 5. And now that lines up with slope-intercept form. In slope-intercept form, when y is all by itself, the number in front of x is your slope. So your slope is negative 7. However, I'm not going to write out negative 7. Remember, slope is rise over run. So rather than saying negative 7, I'm going to make it negative 7 over 1. For my y-intercept is the number that's floating around all by itself once y is all alone. So since y is all alone and 5 is floating around, my y-intercept is 5. Now, when you graph something using slope-intercept form, you always start out by putting your point on the y-axis where your y-intercept is. So I'm going to go to 5 here and put a dot right there on 5. Now, my slope is negative 7 over 1. So that could be up and to the left. So since it's rise over run, I can go up 7, left 1. Well, here's the problem. If I try going up 7, I'm going to run out of room really quickly. So instead of going up 7, left 1, I can go down 7, right 1. So here's my dot. Let's go down 1, 2, 3, 4, 5, 6, 7, and right 1. If we try it again, 1, 2, 3, 4, 5, 6, I run out of room. But that's okay. All you have to do to graph 2 points or to graph a line is all you need is 2 points. I know the Beatles said all you need is love, but in this case all you need is 2 points. So you have your points, you draw your line through those 2 points, and then you're done. So again, solving or rather graphing an equation in slope-intercept form requires you to get y all by itself. Once you do that, identify your slope, identify your y-intercept, put a dot on the y-intercept, and use your slope to put as many dots as you can, draw the line, and you're done. Graph using slope-intercept form. Well, here's my issue. This is not in slope-intercept form, not even close. Slope-intercept form is y equals mx plus b. When you have y all by itself, the number attached to x is your slope, and the number floating around is your y-intercept. This will help me graph, but I'm not even close to that. I have 3x floating around on the same side as y, and I have 5 attached to y. So I have a little bit of work to do. You always want to get rid of the x term first by doing the opposite of what you're currently doing. So since this is a positive 3x, the opposite of positive 3x is minus 3x, and so we'll subtract 3x from both sides. That allows you to cross that out. Drop down the 5y. Now these guys don't combine. And what I want to do is I want to try to make this look like this. So I'm going to write out my x term first, negative 3x, and then I'm going to write out my minus 5 second. So 5y equals negative 3x minus 5. Is y all by itself? No, that 5 is in the way. So how do I get rid of a 5 that's being multiplied to y? Divide by 5. Now when you divide by 5, you literally divide everything by 5 like that. Cross you out. Negative 3 over 5 doesn't simplify, so it's negative 3 over 5, drop down the x. Negative 5 divided by 5 is negative 1. Now that I have y all by itself, I can identify my slope, which is the number in front of x, so let's write that out. Slope is going to be negative 3 over 5. And I can identify my y-intercept, which is the number that's just floating around right there, which is negative 1. Now, in order to graph using slope-intercept form, you're going to start out by drawing a dot on the y-axis where your y-intercept is. So since my y-intercept is negative 1, here's my y-axis. Let's go to negative 1 and put a dot there. Now from there, we're going to draw as many points as we can using the slope. This is a negative slope, which is up and to the left. So this is rise over run. So up 3, left 5. So let's do that. Up 1, 2, 3, left 1, 2, 3, 4, 5. Put a dot there. Up 1, 2, 3, left, oh boy, I'm out of space. So let's go back to our original point that we drew out, and instead of going up and to the left, we can go down and to the right. So down 3, right 5. Down 1, 2, 3, right 1, 2, 3, 4, 5. Put a dot, and we're obviously not going to be able to do it again. But that's okay. We have 3 dots, and once I have 2 dots, I'm good to go. So I'm going to draw a line through my 3 dots the best that I can, like so. And we have ourselves a line that we graphed using slope-intercept form. Get y all by itself, identify the slope and the y-intercept, put a dot where the y-intercept is, use your slope to get more dots, connect the dots, and we just graphed a line in slope-intercept form that was in slope-intercept form to begin with. Graph using standard form. Now standard form is in the form ax plus by equals c. Now there's a few shortcuts if we want to use standard form to help us figure out how to graph it quickly. Okay, now here are the shortcuts, and this is something that you're going to memorize if that's what you decide to do. I'm going to try to find 2 things, the x-intercept and the y-intercept. Now, the way you normally find an x-intercept is you substitute 0 in for y and then solve for x. But the shortcut is if you were to do that, if you were just to pretend that y isn't there, you would have ax equals c. So let's kind of do these shortcuts so you can see what happens. The x-intercept is found by doing ax equals c. In order to get x all by itself, you divide a from both sides, and the shortcut is found by doing x equals c over a. Now we'll figure out what that means in a minute. Similarly, if I were to normally find the y-intercept, the way you do that is substitute 0 in for x. When you do that, the ax goes away, and you're left with by equals c. So in order to get y all by itself, you divide both sides by b. Now, if you're like, I don't like any of this, can we just skip to the shortcuts? Fine, here you are. So the shortcut for the x-intercept is x equals c over a. Well, what's a, b, and c? Well, if your ax plus by equals c and your 3x plus 5y equals negative 5, then my a is going to be 3, my b is going to be 5, and my c is going to be negative 5. So, my x-intercept is going to be negative 5 over 3. Not pleasant, but that's what it is. My y-intercept is going to be c over b, which is negative 5 over regular 5, which simplifies to negative 1. Now, what I do is I put points where those intercepts are. So the x-intercept is negative 5 over 3. Now, negative 5 over 3 is the same as 1.6 repeating. So we go to the x-axis, and we go to where we think is 1.6 repeating, and we put a dot right there. We go to the y-axis, and we go to negative 1. So here's the y-axis. My y-intercept is negative 1, so let me get some colors out. Negative 1. And we put a dot where we think is our y-intercept. Now that's a whole lot more pleasant than negative 5 over 3. Now what we can do that we have two dots is we can connect those dots and we can be done with the problem. And this is me trying to do the best that I can, and I'll give myself a little bit of credit. That's not too bad. But that's how you graph using standard form. It's not the best thing to do, not the best idea, but that's how you would do it if that's the way you decide to do it. You could use these shortcuts right here. Write the slope-intercept form of the equation of the line through the given point with the given slope. All right, so this requires a little bit of work. These are never the easiest problems on the planet, but this is how you're going to do it. Slope-intercept form is y equals mx plus b. What you're going to want to do first when you use this method is you're going to find your slope first. So step number 1 is find your slope. Well, that's wonderful. The slope is 7, so m is going to equal 7. Once we have that, you're going to write out what you have so far. So problem 2 is so far we have y equals, my slope is 7, so 7x plus b. Now step 3 that we're going to do is once we have our slope, we're going to take our point and we're going to label our point x and y. We're going to take that and plug that in. So the y is going to be 2. We're going to replace y with 2. And we're going to replace x with 1. And that'll help us find b. So 2 is 2. 7 times 1 is 7 plus b. In order to solve for b, you subtract 7 from both sides, like that. And you get negative 5 is equal to b. Or b is equal to negative 5, however you want to view it. Now, last but not least, step 4 is you put it all together. In step 2, I found out that y equals 7x plus b. I just found out that b is negative 5. So what I have when I put it all together is y equals 7x plus negative 5. Now, that looks sloppy, so my final answer is going to be y equals 7x minus 5. So if you are being asked to write an equation in slope-intercept form and you're given the slope and a point, identify your point, right? I'm sorry, identify your slope, write out what you have so far, use your point to find out b, and then step 4 is put it all together and you're done. Write the slope-intercept form out of an equation of the line through the given point with the given slope. So we're given a line that goes through 2, 5, but also has an undefined slope. This is a special case. An equation that has an undefined slope means it's a vertical line. Looks a little something like that if I knew how to draw a vertical line. Now, a vertical line is in the form x equals a number. So my job is to find out what x is. Well, we know x is 2 because 2 is an x value. So my answer is x is 2. So again, when I'm given an undefined slope and I'm asked to find the equation of a line that is an undefined slope, it's going to be x equals a number. And then the number that I choose is completely based off of the fact that 2 is my x value, and so x is 2 is going to be the equation of that vertical line. That's it. Write the slope-intercept form of the equation of the line through the given point with the given slope. Well, here's the thing. I'm not given a slope. I'm given 2 points. So what I need to do is I need to find the slope. So let's remind ourselves that slope-intercept form is y equals mx plus b. When y is all by itself, the number in front of x, the number attached to x is my slope, and the number floating around is my y-intercept. Well, here's the issue. I don't have a slope. So what I need to do is I need to find the slope by using the slope formula. The slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, the way I get my y's and x's is I go up to my point up here and I label both of my points. I'll label one point x sub 1, y sub 1, and I'll label the other point x sub 2, y sub 2. Now, it doesn't matter which point I call which as long as it's x, y, and the numbers are consistent. But now that I labeled that the way I did, I can plug things in and find my m. So I'm going to replace y sub 2 with parentheses 1, minus is minus. I'm going to replace y sub 1 with parentheses negative 8. Draw out my fraction bar. I'm going to replace x sub 2 with parentheses negative 4. Minus is minus, and I'm going to replace my x sub 1 with parentheses 5. So let's clean this up. Let's do a little bit of math. 1 minus negative 8 is going to be the same thing as 1 plus 8 because then double negative makes it a positive. Negative 4 minus 5, nothing changes there. Negative 4 minus 5. 1 plus 8 is 9. Negative 4 minus 5 is negative 9, and 9 divided by negative 9 is negative 1. So after all of that, I finally have a slope, and that slope is negative 1. So what I do is I write out the fact that so far, if I know that's an E, so fair, or so far, I know that y equals mx plus b, and I just found that m is negative 1. So y equals negative 1x plus b. Well, I don't like that. I don't need that 1 there. So y equals negative x plus b. Look at that. Lots of erasers today. Now, am I done? No. I need b. So what I'm going to do is I'm going to pick any of these points, and it doesn't matter. I'm going to pick any of these points and call it xy because any point is xy, and I'm going to substitute the x and the y that I just chose into that. Again, it doesn't matter which point that I choose, I'll get the correct answer anyway. So y becomes negative 8 in parentheses equals negative drops down, x becomes regular 5, and then drop down the plus b. Okay, negative 8 is negative 8, negative 5 is negative 5, and then plus b is plus b. Add 5 to both sides to get b all by itself, and b is going to equal negative 3. So now that I know that y equals negative x plus b, but b is negative 3, I could say y equals negative x plus negative 3. Now that looks kind of sloppy, so I'm going to write this out as y equals negative x minus 3. So lots to do, okay? Lots of sloppiness to deal with, but that's how you find slope-intercept form when given 2 points instead of just given the slope and the y-intercept. Write the slope-intercept form of the equation of the line through the given point with the given slope. So first things first, slope-intercept form looks like y equals mx plus b. When y is all by itself, the number in front of x or the number attached to x is my slope, and the number floating around is my y-intercept. Now let's see what I have. I have a line that's supposed to go through negative 6, 1, but is perpendicular to y equals negative 3/4 x minus 5. So here's the trick. In order for me to write out my equation, I need to find a slope and a y-intercept so I can plug them in for m and b and be done with it. I'm not given a slope. I'm not given a y-intercept. This is what I'm given. I'm given the fact that this line, the one that I have to create, has to be perpendicular to that line. Now, perpendicular lines have slopes that are negative reciprocals of each other. When I look at this guy has a slope of negative 3/4. The slope that I want has to be a negative reciprocal of that. The way you find the negative reciprocal of a fraction is you flip the fraction, so 3/4 becomes 4/3. And since this is already negative, you take the opposite of that, and that becomes positive. So the negative reciprocal of negative 3/4 is positive 4/3. So the slope that I want is positive 4/3. So let's write out what I have so far. So far, y equals 4/3 x plus b. Now I have my slope. What I don't have is my y-intercept. How do you find your y-intercept? Well, you have to find b. I know that this is a point, and points are in xy form. So if I'm going to label u x and I'm going to label u y, when I find b, I can replace y with positive 1, and I can replace x, so 4/3, replace x with negative 6. And then we just solve for b. So 1 is 1. 4/3 of negative 6 is going to be negative 8. Use a calculator if you need to. And then you add b to it. In order to solve for b, I'm going to get rid of negative 8 by adding 8 to both sides. Add 8 to both sides. And that gives me a b of 9. Now that I know that my equation so far is y equals 4/3 x plus b, and I just found out that b is 9, I can sum things up by saying y equals 4/3 x plus 9. And that is the equation of a line perpendicular to that guy and goes through that point. That's it. Write the standard form of the equation of the line through the given point with the given slope. All right, standard form looks like this. ax plus by equals c. Here's the thing. A and b have to be integers, no fractions. So this is what I'm going to do. I'm going to first turn this into slope-intercept form, which looks like this. Once I get slope-intercept form, I'll then turn that into that. Now, in order to turn this into slope-intercept form, I need to identify what I have so far. I have a slope of 2. So what I can write out so far is that y equals, instead of m, 2x plus b. I don't know my y-intercept yet, but this is what I do know. It goes through the point negative 1, 2. Points are in xy form. So I can take this y and replace it with parentheses 2. I could take that x and replace it with parentheses negative 1, and that'll help me find b. So 2 is 2. 2 times negative 1 is negative 2, plus b. Add 2 to both sides, like so. b equals 4. And when I put it all together, When I put it all together, I have y equals 2x plus 4. Now that is my slope-intercept form. I need to make u look like that. And this is going to just require one step. So let me write it out. Basically what I need to do is I need to get both my x and my y on the left side and make sure that they're not fractions. Well, in order to get 2x from the right to the left, I subtract 2x from both sides, like that. Negative 2x and a positive y don't combine, so I have negative 2x plus positive y equals positive 4, and that is me writing an equation in standard form. So kind of seems like it's a bit too much, but that's what we're asked to do, and that's what I did. Write the standard form of the equation of the line through the given point with the given slope. Standard form is ax plus by equals c, where a and b can't be fractions or decimals. They have to be regular old integers. Now, in order for me to do this, what I need to do is first put this in slope-intercept form, which is y equals mx plus b. So let's see what I have. I'm given a point and I'm given a slope. So what I have so far and what I know is when it's in slope-intercept form, the number in front of x is my slope. So far, y equals 1/2 x plus b. I know my slope is 1/2, so y equals 1/2 x plus b. Now I have my slope, I don't have my y-intercept. How do I find my y-intercept? Well, I can label ux, I can label uy, plug those in, and that'll help me get b, which is my y-intercept. So I've labeled u, xy, so y is 1, so let's write out y is 1. 1/2 of x, so 1/2 of 3 plus b. Okay, 1 is 1. 1/2 of 3 is 3 over 2 plus b. Now, what I'm going to do is I'm going to turn 1 into 2 over 2 because 1 is 2 over 2. And if you're wondering why, well, my next step is to subtract 3/2 from both sides. And when I do that, now I can combine fractions. 2 over 2 minus 3 over 2 is negative 1 over 2, and that's what my b is. So when I take this and put it all together, I have y equals 1/2 x plus b, or plus negative 1/2. So let's write that out one more time. Y equals 1/2 x plus a negative means minus 1/2. Now I need to make u look like u, and u have a and y both on the left. I can't have that, so let's subtract 1/2 x from both sides, and that'll eliminate what I have on the right. That'll eliminate my x from the right. Negative 1/2 x and positive y don't combine, so I have negative 1/2 x positive y equals negative 1/2. Now here's what I said before. What I said before is a and b have to be integers. So what I'm going to do is I'm going to notice that you are a 1/2. In order to make 1/2 a regular number, an integer, I multiply it by 2. And if I multiply the left by 2, I have to multiply the right side by 2 as well. So you distribute that, you get 2 times negative 1/2, which ends up being negative 1. So let me write that over here. Negative 1x, so negative x. 2 times positive y is going to be plus 2y. And on the right side, I have negative 1/2 times 2, which is negative 1 again. So now it's in standard form. And once it's in standard form, we're good to go, and everybody's happy. Was it pretty? No. But did we do it? Yes. And don't you feel good about yourself? You should. Write the point-slope form of the equation of the line through the given point with the given slope. Point-slope form is awesome. It's y minus y sub 1 equals m times the quantity x minus x sub 1. Now, it doesn't look as nice as slope-intercept form, but it's great. The m is still the slope. If you're wondering, well, what's x sub 1 and y sub 1, that's going to be your point. So in order to do point-slope form, you label your point x sub 1, y sub 1, and you label your slope m. So what I have is I have everything I need. I just take that guy and plug it in. Y minus y sub 1 is parentheses 1 equals 1/2 instead of m parentheses x minus 3 parentheses 3 for x sub 1, right? And then get rid of the parentheses and you're done. It's just the one thing that you have to be careful of here are double negatives. I didn't have any double negatives, so this problem was kind of nice, but that's what point slope form looks like. It doesn't look perfect because you'd think, oh, well, y should be all by itself, but nope. Point slope form is exactly for when you have a point and a slope, and that's what I was given. Easy peasy. Write the point-slope form of the equation of the line through the given point with the given slope. Point-slope form is y minus y sub 1 equals m times parentheses x minus x sub 1. M is your slope, and x sub 1, y sub 1 is your point. Now I have almost everything I need. What I do is if I'm given a point, label the point x sub 1, y sub 1. If I'm given the slope, label it m. I'm not given the slope, but what I am told is the slope that I need has to be parallel to this equation right here. Well, this is slope-intercept form. The slope of this guy is -3/4. Parallel lines have the same slope, so the slope that I want is going to be the exact same slope. So now that I know that I have a point of x sub 1, y sub 1, and a slope of -3/4, I can plug it all in. Y minus, instead of y sub 1, I'm going to write out parentheses 2, equals, and instead of m, I'm going to write out -3/4, parentheses x, minus, instead of x sub 1, I'm going to write out 4, and those parentheses were overkill. I don't need them. Drop down y minus 2 equals -3/4. X minus 4 is x minus 4. And I have my guy. Now that looks like it should be wrong because y is not all by itself, but it's not. Point slope form looks like that, and that's what we end up getting. Write the point-slope form of the equation of the line through the given point with the given slope. All right, so we need point-slope form. Let's write that out. Y minus y sub 1 equals m times the quantity x minus x sub 1. Now, what is what? M is the slope, and x sub 1, y sub 1 represents the point. What I have here is actually I'm not given the slope. I'm given 2 points. So what I'm going to do is I'm going to label you x sub 1, y sub 1 because you're a point. And I'm going to label you x sub 2, y sub 2. Now what this does give me is this does give me a point. That's nice. What it doesn't give me is the slope. But you know what? If I'm given 2 points, I can use this guy right here, the old slope formula, and that'll help me find the slope. So let's use the slope formula using those 2 points to find my slope. I labeled y sub 2 1, so let's put parentheses 1. The minus sign is the minus sign. Y sub 1 is -4, so parentheses -4. Okay, fraction bar. X sub 2 I labeled -7. Minus sign is minus sign. X sub 1 is -10. So let's clean this up a little bit. 1 minus -4 is 1 plus +4, so let's say that. -7 minus -10 is -7 plus +10, so let's write that out. 1 plus 4 is 5. -7 plus 10, or 10 minus 7 is 3, and that's my slope. So what I have is I have a slope of m equals 5/3, and I have a point labeled. So now we have enough information to put it all together. So y minus y sub 1 I'm going to write out as y minus parentheses y sub 1 is -4 equals, my slope is 5/3, so let's write that out, x minus x sub 1 I called -10. And let's take a second to clean that up. We have a double negative, so y plus 4 equals 5/3, parentheses, x plus 10. Now this is usually the part of the video where I put a circle around everything and say we're done, hooray. But here's the thing. I gave you 2 points to start out with. What's to stop you from calling this point x sub 1, y sub 1, and this point x sub 2, y sub 2? Well, there's nothing stopping you from doing that. You're allowed to do that and you'll still end up with the same slope. So if you were to do this guy, and if your friend were to, for whatever reason, flip this around, and they would write out this, so maybe let's just say that they did that, and you did y minus, and instead of y sub 1, they did 1, equals the same m, 5/3, parentheses, x minus negative 7, negative 7, negative 7, negative 7, and then they clean it up to make it look like this, y minus 1 equals 5/3, x plus 7. It's still the same answer. Does it look the same? Absolutely not. But if I were to distribute 5/3 and then subtract 4, and if I were to distribute 5/3 and then add 1, I'm going to end up with the same exact guy. So both of these are technically correct. So it all depends on what you label your points. But as long as you label your points and you're consistent, you might have 2 different answers, but those answers will be the same. So that's how it's done. Graph the inequality y is greater than or equal to negative 3x plus 4. When you graph an inequality, you start out by treating it like it's a regular old equation in the form y equals mx plus b, where m, the number in front of your x, is your slope, and b is your y-intercept, as long as y over here is all by itself. Y is all by itself, so we can label the slope -3. Now I'm going to call the slope -3 over 1 because slope is rise over run and it's better to view it that way. My y-intercept is 4. And so again, we start out by graphing this the same exact way that we would graph a normal equation. We start at the y-intercept, put a dot at 4 where the y-axis is, and then use our slope to put as many dots as we can. So this is a negative slope, which goes down and to the right or up and to the left. So I'd go up 3, left 1, up 3, well, I can't, left 1. So maybe I'll go down 3, right 1, down 3, right 1, down 3, right 1, and make as many dots as I can. Now is where things change. So thing number 1 that we need to look at is the fact that we're given a greater than or equal to symbol. Okay, when you're given the or equal to symbol, that means that you're allowed to include the line. So if you're looking at these and if you're wondering, why is there 2 lines up there instead of 1? I am choosing the one that includes the line. So when it's or equal to, you draw out a solid line like so. Now, I'm not done yet. The other thing that we have to notice is that y is greater than or equal to 0, which means I'm going to do some shading. Okay, so the shading that I'm going to do, since this is a greater than or equal to symbol, is everything above the line, which is going to be here. Let me get a larger pen. Oh boy, this is going to take a very long time. Now, what this means is, since this is an inequality, okay, is I have an infinite amount of answers. In this shaded area, any point in this area is a possible solution. Any point in this area is a possible solution. For example, if I were to choose this point right here, 4, 4, that means if I were to plug in the point 4, 4, into x and y, I'm going to get a true statement. Since this is or equal to, I can also choose points on the line, like 0, 4. And if I choose 0, 4 and plug it into the original inequality, I'm going to get a true statement. In fact, I would get y is greater than or equal to 4, or 4 is greater than or equal to 4, which is a true statement. So when you graph an inequality, you are created a shaded region that says all of these points are possible answers to the original inequality right there. Graph the inequality y is less than or equal to 3/5 x minus 5. The way you graph an inequality on a coordinate plane is you start out by treating it like it's a regular old y equals mx plus b problem, where the number in front of x is your slope and the number that's floating around is your y-intercept as long as y is all by itself. So I'm going to start out just like this. I'm going to notice that my slope is 3/5. I'm also going to notice that my y-intercept is -5. And I'm going to place points based off of that information. So I'm going to start out always by putting a dot where the y-intercept is on the y-axis right here. And I'm going to use my slope to make more dots. So my slope is 3/5, which is positive. So up 3, right 5. So up 1, 2, 3, right 1, 2, 3, 4, 5. Put a dot there. I can't go any more. I can't go down 3 and left 5. So I only have 2 dots. Now this is where things kind of become brand new. Okay, this is where things get different. With an inequality, there's 2 differences. Difference number 1 is in both cases, you look at the symbol that you have. Difference number 1 is if it's or equal to, like this is, you are going to use a solid line because you include the line as part of your answer. The dashed line means you don't include it. The solid line means that you do. So I'm using the solid line because it's or equal to. The other thing that I have to pay attention to is the fact that it's less than. So when it's less than, what you do is you shade underneath the line. Now by shading underneath the line, what we're doing is we're saying all of these points here in purple are possible answers to the original problem. For example, if I were to take the point, I don't know, 4, -5. If I were to take the point 4, -5, label you x and y, and plug it into the original inequality, it'll give me a true statement. So when you graph an inequality, you shade a side that says all of the points on the side that I shaded are possible solutions to the original inequality. And in this case, since we're including the line, you can also plug in any of the points on the line and that'll also give you a solution. So I can plug in 5, -2 right here and it'll give me a solution that will also work. So when you are graphing an inequality, you shade a side, you make a solid or dashed line, and anything that's shaded or on the solid line is going to be a possible solution. And that's it. Graph the inequality y is greater than -x minus 5. When you graph an inequality, you start out like graphing a regular old y equals mx plus b problem in slope-intercept form, where when y is all by itself, the number in front of x is your slope, and the number floating around is your y-intercept. In this case, when I take a look at this, I'm going to compare this to y equals mx plus b and notice that my slope is negative, or in this case, my slope, since it's negative, invisible number, it's going to be -1. And my y-intercept is -5. I don't know why I put a double negative there, but I did. That's my y-intercept. So my slope is going to be -1. My y-intercept is going to be -5. So I'm going to start out by putting a dot at -5 like so. Now the slope of -1 I'm not a fan of, so let's turn that into -1/1. And then we're just going to go, since this is a negative slope, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, and do that as many times as humanly possible like that. If I can't go up 1, left 1, I can go down 1, right 1. Now this is where it's new. This is where the game changes a little bit. When you graph an inequality, now that we have our dots, we need to take a look at the symbol that we're given. This symbol is greater than. Now, there's no or equal to part, which means we don't include the line. So when we choose a line to graph, when we don't include the line, you make a dashed line. The dashed line means that the line itself doesn't count. So if it's less than or greater than, you make a dashed line. If it's less than or equal to or greater than or equal to, you would make a solid line. Now, the other thing that we're looking at is the fact that this is greater than. So when it's greater than, what you do is you shade above the line. Now, I'm not going to completely shade this because then this video would be a half an hour long, but we're going to shade above the line. Now, as I'm shading, this is what this means. Anything in this purple shaded region, any point in this purple shaded region is a possible solution to the original problem. Okay, so the original inequality is y is greater than or equal to negative x, y is greater than negative x minus 5. What that does, since this is an inequality, is this gives me an infinite amount of possible answers. So you're a possible answer, and you're a possible answer, and you're a possible answer. Even 0, 0 is a possible answer. Because if I were to take 0, 0, label u x, label u y, and plug that into the original problem, I would get 0 is greater than negative 5, which is a true statement. So when you graph an inequality, you shade a region that tells you that all of these points are possible solutions to the original inequality. I can't include any point on the line because you're not counting the line, it's dashed. But everything in the purple region here will work, and that's how you graph an inequality. Graph the inequality x is less than negative 5. Well, we know from back in the day that anything that is x is equal to some number is going to be a vertical line. Well, there's a little change here. This isn't x is equal to a negative 5. This is x is less than. However, that doesn't change anything. This is going to be a vertical line, and it's going to go through negative 5. Now, this is where we have to be careful. Look at the symbol. The symbol is less than. It's not less than or equal to. So when we graph an inequality that is either less than or greater than, you graph a dashed line. So I'm going to choose this dashed line and have it go through negative 5. The dashed line means that the line doesn't count. You're not allowed to include any points on this line right here. Now, the other thing that you look at when you graph an inequality is the symbol, and that tells you which side you need to shade. I have x is less than negative 5, which means I'm going to shade everything to the left of negative 5 because it's to the left of negative 5. That's what less than means. Now, what this means is I can choose any point in this green shaded region, and that'll give me a true statement. So what that might look like, and this might seem bizarre, but bear with me here. Like if I choose negative 6, 0, negative 6, 0, I would label u the x and u the y. And I would go over here and say, all right, well, let's plug in negative 6 for x and 0 for y. So negative 6 for x. And wait a minute, there is no y. Exactly. So don't worry about it. You get negative 6 is less than negative 5, which is a true statement. So since we don't care about the y's really don't matter. You're just going to plug in the x value that you get. So anything to the left of negative 5 is going to be a possible solution no matter the y. And that's how you graph an inequality when you're given just one letter to use. The end. Graph the inequality x minus y is greater than 2. When you graph an inequality, you start out by graphing a regular line in the form y equals mx plus b. Well, here's my issue. Y is supposed to be by itself. Over here, y isn't all by itself. So we have to get y all by itself by solving for y. And so we're going to follow all of those rules that might have to flip your signs and stuff like that. So let's do it. In order to get y all by itself, we have to first get rid of this positive x that's floating around. How do you get rid of a positive x that's floating around? Subtract x from both sides. Drop down minus y is greater than, and you have a 2 minus an x. I want to make this look like slope-intercept form. So I'm going to put the negative x first and the positive 2 second. Now, is y all by itself? No, I have a negative floating in the way. So what I can do is I can divide everything by negative 1, and that'll allow that negative y to become positive y. Whenever you have a greater than, and you divide both sides by a negative, you flip the sign. Negative x over negative 1 becomes positive x, and positive 2 over negative 1 becomes minus 2. Now I have my correct inequality to graph. So I can compare it to this guy over here, where you're given y equals mx plus b, m is the slope, b is the y-intercept. Okay, now when I look at this, I don't have a number in front of x, which means my slope is an invisible positive 1, or 1 over 1. Negative 2 is all by itself, so that's fine. So far, not much has changed as far as me graphing the inequality. I haven't even graphed it yet. We're still going to start out by putting a dot at negative 2 on the y-axis, and then we're going to use our slope to go up 1, right 1, because it's a positive slope, up 1, right 1, up 1, right 1, and make as many dots as we can. And if I can't go up 1, right 1, I can go down 1, left 1, down 1, left 1, down 1, left 1 a bunch of times. Now this is where things get brand new. This is an inequality. And when I graph an inequality, I need to take a look at the inequality symbol. This is a less than symbol. With a less than symbol or a greater than symbol, you are going to graph using a dashed line. And if you're wondering why, it's because a dashed line means that the line itself isn't included, because it's not equal to, it's just less than. So we're dashing the line and we're leaving it not solid. The other thing we need to look at is we need to shade a side. Since this is less than, we're going to shade underneath the line. Now by shading underneath the line, what we're doing is we're saying everything that's here in this blue shaded region, any point that we choose in this blue shaded region is a possible answer to the original problem. So if I wanted to, I could choose any random point in this blue shaded region, like, I don't know, 5, negative 1, and I can say that's 5, negative 1, and we can label u x and we can label u y, and we can plug it into the original equation, and that'll give us a true statement. So when you graph an inequality, you are trying to find a set of points that when you were to plug any of these points in, gives you a true statement. So again, we can plug in anything here in the shaded blue region. We can't plug in anything on the line though, because the line doesn't count. But anything that's shaded is fair game. And that's how you do it. Graph the inequality 3x minus 2y is less than 10. Alright, so in order for us to graph an inequality, we need to get this into slope-intercept form, which looks like this. Now I know this is an equal sign, this isn't. We'll deal with that in a minute. I just need to get y all by itself over here. That way I can compare it to this. So in order to get y all by itself, we need to first get rid of 3x by subtracting 3x from both sides, like that. Drop down the negative 2y. Drop down the less than, and I have 10 and a negative 3x. Now, I'm going to write out my negative 3x first, and then my positive 10, to make it look more like this. Now, is y all by itself? No, I have negative 2 being multiplied to y. So how do we get rid of a negative 2? Divide everything by negative 2, which means something happens. When you take an inequality and multiply or divide by a negative, you flip the sign. Like that. So since we divided by negative 2, less than becomes greater than. Negative 3 over negative 2 becomes positive 3 over positive 2. X comes along for the ride. Positive 10 divided by negative 2 becomes minus 5. Now you look like slope-intercept form. Remember, slope-intercept form says that when y is all by itself, the number in front of x is my slope and the number floating around is my y-intercept. So looking at this problem right here, my slope is going to be 3 over 2 and my y-intercept is going to be negative 5. So you make dots the way you normally would. Start at negative 5, put a point there. Since this is a positive slope, we're going to rise 3, run 2, so up 3, right 2. So up 1, 2, 3, right 1, 2, put a dot. Up 1, 2, 3, right 1, 2, put a dot. Up 1, 2, 3, right 2, put a dot. That's all the points that I can draw. Now, this is where things get different. This is a greater than symbol, which means we have to focus on two things. Since it's a greater than symbol and not a greater than or equal to symbol, we're not allowed to include the line. So we choose the dashed line. A dashed line means the line's not included. So we draw a dashed line through these points like so. Now that's thing number one. Thing number two is this is a greater than symbol, which means you're going to shade everything above the line. Now, when you shade a bunch of points, what you're basically saying is any point that I choose in this green shaded region, okay, any point that I choose in this green shaded region is a possible solution to the original problem. So I could choose something like 0, 0 and label 0, 0, x and y. And when I plug 0, 0 in, I would get 0 is less than 10, and that's a true statement. So when you graph an inequality, you make a line and you shade. And anything that's in the shaded area or on a solid line is going to be a point that is a possible solution. So we have infinite solutions going on here, and those solutions are any of these points in the green shaded region. Again, I'm not allowed to include the line because it's greater than, or in this case less than, and there's no or equal to part. But that is how you graph an inequality. All right, let's graph this absolute value equation. Now, with absolute value equations, it's kind of unique, and you could always make a table. You've probably watched my videos where I've done that, and if you haven't, go back and watch those videos because they're great. But here's a shortcut. Okay, and you kind of have to have this memorized. It's not the easiest thing to memorize, but if you have it in your head, you'll be good. What A does is A gives you a slope, and if A is positive, it opens up, and if A is negative, it opens down. Okay, B tells you where to go left or right, and C tells you where to go up or down. Now, when I look at this, this is a very, very, very basic absolute value equation. I have 1, invisible 1, living in front of x. I have nothing living with x, so you're not moving left or right. But what you are going to do is you're going to move up 1. So the best way to view this is you have a slope of 1, or 1 over 1, opening up like this, and you start it by shifting it up 1. So you start at 0, you shift up 1, and then you have a slope of positive 1 like this, and a slope of negative 1 like this. And then your graph is going to be you connecting the dots like this, if I know what I'm doing, if I can draw a straight line, which I absolutely can't. You're seeing that right now. But that's the shortcut. So maybe when the problems get more complicated, watch my next videos. It'll kind of be a little bit clearer because right now I don't have a ton going on here. But once I introduce more numbers, it'll become a little bit more clear. Graph the absolute value equation. There's a shortcut for absolute value equations, and it requires you to memorize this little formula right here. Y equals A times the absolute value of x minus b, close the absolute value, plus c. What A does is A is the number living in front of the absolute value. If A is positive, it opens up and it acts as a slope. So A is your slope. If A is negative, it opens downwards, like that. B tells you where to move left or right, depending on if it's positive or negative, and C tells you where to move up or down. So when I look at this, I have an invisible 1 living in front of my absolute value, which means my slope is going to be 1s opening up like that. Okay, that's my slope. Now you have to be careful. This is x minus b. So if I'm comparing this to x minus b and negative 2 equals negative b, that means b equals 2. So where I'm going to start this is I'm going to move it to the right 2. So basically whatever that is opposite from what we're used to. C here is minus 4, so we're going to start out by moving down 4. That's my C. Okay, so I go right 2. I go down 4, and I put a dot. My slope is positive 1, so we're going to go up 1, right 1 a bunch of times, up 1, left 1 a bunch of times, and make as many dots as we can, like so. Once we have all of our dots, we connect them like that. I'm not good at drawing lines, as you can see from me just going wobbly right there. Awful. But that's the idea. If I knew how to draw straight lines, it would be a whole lot better. But again, yeah, you use this guy right here to find slope and where you move. And once you move it like the Madagascar animals, you're in good shape. Graph this absolute value equation right here. Y equals negative absolute value of x minus 2, close the absolute value, plus 4. You are going to compare this to this formula right here. Y equals a times the absolute value of x minus b plus c. What a does is a gives you slope. And whatever a is, if a is positive, it opens up and the slope behaves that way. If a is negative, it opens down and it behaves that way. X minus b inside the absolute value is going to give a b. If it's a positive b, you move right, and if it's a negative b, you move left. That's where you're going to start. This c living out here also has you starting. If it's positive, you move up, and if it's negative, you move down. So let's see what I have over here. I have a negative living outside. That's a negative 1. So that tells me that this is going to open up downward where my slopes are going to follow a negative 1 pattern or a regular 1 pattern depending on which way you're going. Now this is where you have to be careful. Inside the absolute value I have x minus b. Okay, so if I'm comparing x minus 2 to x minus b, b is not negative 2 because these negatives kind of cancel each other out. B is regular 2. Which means we start by going right 2. So whatever happens inside the absolute value, what you think is going to happen is actually going to be the opposite. Now outside the absolute value is normal. That's plus 4, so I'm going to start up by going up 4. So you begin your problem by going right 2, up 4, right 2, up 4, and putting your dots there. The slope is negative 1 opening downward. So here's me doing negative 1. Going that way, and if it is an absolute value, it's going to create that V, and in this case, an upside down V, and so I'm putting as many dots as I can. Once I get my dots on board, I'm going to go up and to the right like so, and then I'm going to go down and to the right like so, and we have ourselves an absolute value equation graphed. So you're kind of looking at what you're given here. That determines your slope. That determines left or right, opposite of what you expect. That determines up or down, regular. You put your dot wherever you're supposed to begin and use your slope to do the rest, create your V or upside down V. Fun stuff. Direct variation. Find the constant of variation. Well, direct variation is in the form y equals kx. Your constant of variation is the number living in front of x when y is all by itself. So look, y is all by itself. Look, there's my constant of variation. K equals 8 over 13, which means I'm done. This was fun. Thanks for watching. Have a great day. If y varies directly as x and y equals 14 when x equals 3, find y when x equals 6. This is direct variation. Direct variation is in the form y equals kx. Right now, I don't know what k is. K is my constant of variation. So what I need to do is I need to take part 1 here and find k. So if y equals 14, I'll replace y with 14. K is still k. If x equals 3, I'll replace x with 3. Is k all by itself? No. How do I get k all by itself? Divide 3, divide 3. that crosses out. 14 over 3 equals k means k equals 14 over 3. Now that I have that, I could take this information and create an equation for direct variation. Y equals 14 thirds x. Why is this helpful? Well, since I know that, I can find y when x is 6, and I do that by replacing x with 6. Y equals 14 over 3 times 6. Okay? Y equals, when you multiply those together, you're going to get some number over 3, but that simplifies out to 28. So y is going to equal 28. So the way you do this is you build your equation for direct variation. Once you have that, it's built. You plug in the number you're given to find the other number, and you're good.